Okay, let's start our meeting today. Today we will cover, let me see the discussion first. Today we will cover 5.6, 5.7, 6.1. And the emphasis will be on 6.1. Basically, I will do 5.6, maybe like around half an hour. And then 5.7, maybe around 1 hour. No, 45 minutes, 1 hour at most. And then 6.1 will be approximately 1 hour. This 6.1 will also mark the end material for your test 3. Your test 3 basically will be from logarithm, which is 4.4. Let me make sure. Yeah. So your test, let me edit this. Your test 3 will be from 4.4 from 4.4 to 6.1. Okay, 4.4 to 6.1. Let me see if I skip any section. As I remember, I didn't skip anything. Oh, I did skip some. Oh, no, I actually did all of them. Yeah, it's all of them. Okay, up to that one. Now, but the reason I show you this is because especially what I will do today, relies heavily on that you already watched the recording for today and last time. So today we supposed to watch, by today you're supposed to have watched lesson 18. Okay, now what I will go over today actually covers part of lesson 17, the proofing. Okay, and then 5.6, 5.7 in lesson 18. Okay, now then by this Thursday, please make sure that you already watched lesson 19. Okay, otherwise we will get really, really slow. You know, I know that most of you, if not all, did not have background in trigonometry. That's why I provide you those lecture videos. Okay, now then let's go on. Today we will do 5.6, 5.7, and 6.1. Now 5.6 is on additional trigonometry graph. This is not considered as important compared to 5.5. Okay, in this 5.6, we will describe the graph of tangent, cotangent, secant, and cosecant. As I remember, I never really asked students to graph, to actually graph tangent, cotangent, secant, cosecant. Okay, but I need you to realize and see the domain, range, and asymptotes of each one of them. Okay, now let's start with the graph of tangent x and the graph of cotangent x, things that we want to memorize here. Okay, the graph of cotangent, this is the graph of, I'm sorry, the graph of tangent x. This is the x-axis. This is the y-axis. Okay, now the graph goes actually from lower left going to upper right, and it repeats that cycle again and again every pi. So you can see that the period actually pi only because it repeats the cycle every pi units. You see? Okay, if you look at this window here, okay, now this window you repeat again here. You repeat again here. Okay, That's why we say that the period is pi. Now, however, the function, the tangent function is continuous in this window. It's continuous in this window from negative pi over 2 to pi over 2, and then from pi over 2 to 3 pi over 2, from 3 pi over 2 to 5 pi over 2, okay? And we have this window also here, okay? Now notice that the axis that I skip give us the asymptotes. Okay, now from here, from that graph, then we observe a couple things. First one, what is the domain? The domain of tangent x is all real numbers except pi over 2 plus integer multiple of pi, where k is an integer. Okay, so every pi over 2, you skip that, okay? And every pi after or before that. Now, you may wonder why. And that's the reason I go over this right now. Why is that domain is all real number except this, except at this axis here? Why? Now, the reason is actually at the function tangent, note that tangent x, note that tangent x is equal to sine x over cosine x. Okay, so tangent x is undefined when sine x equals to 0. I'm sorry, cosine x equals to 0, the denominator, when cosine x equals to 0. So far so good. Now, when will cosine x equals to 0? Cosine x equals to 0 when the angle is 90 degrees or pi over 2, or when the angle is 270 degrees. Okay, when the angle is pi over 2, or when the angle is 3 pi over 2. Now you can see it this way. You can see it this way. You can see that cosine x is equals to 0 when theta is pi over 2, or every 180 degrees after that, every pi units after that. Okay, so at pi over 2, and then you add pi, you get 3 pi over 2, you add pi, you get 5 pi over 2, you add pi, you get 7 pi over 2, and so on and so forth, right? As long as it hits this position and this position. Okay, now, therefore, when will cosine x equals to 0? That's when x equals to pi over 2 plus any integer multiple of pi. Okay, any integer multiple of pi, where k is an integer. That's how we get that the domain is all real number except when x is pi over 2 plus or minus, of course, the k is a positive negative integer, plus k multiple of pi. Now, that's the domain. Now, the thing is that axis that we need to exclude from the domain also give us the asymptotes. Okay, so the asymptotes, vertical asymptotes, are the axes that we exclude from the domain. It feels like buy one, get one free, you know? If you can find the asymptotes, you will get the domain. If you get the domain, you find the asymptotes. Okay, the range in this case is all real numbers. As you can see from the graph, the range actually all real numbers. That's right. Okay, the range is all real numbers. Okay, now that's for tangent. Period, oh yeah, you know what? The period is pi. I mentioned that earlier, but I forgot to write it here as something we need to talk a little bit. Now, because the range is all real numbers, therefore there's no notion of amplitude when it comes to tangent. Okay, there's no notion of amplitude for tangent. And if we switch our view to cotangent, the graph next to it, you see that this is the x-axis, and this is the y-axis. Oh, I need to emphasize that. Do you realize that tangent x is an odd function? You see, if I take this graph here and I rotate that 180 degrees, it look the same, right? It look the same. I can't even fit it back. You see? Okay, it look the same. I mean like this. Yeah. Okay, I already rotate this 180 degrees. Let me put it back. Yeah, this is the original graph. Okay, so tangent x is an odd function. Now, cotangent x, also an odd function. You can actually show that by doing this. Tangent x is an odd function. Now, the proof of that statement, what you do is like take a look on tangent negative x. Tangent negative x is sine negative x over cosine negative x, right? But sine is known to be, sine negative is negative sine, but cosine negative is just cosine itself. This is equals to negative tangent x. But that proves that tangent is an odd function. Okay, to be more precise, y equals tangent x is an odd function, to be more precise. It means it has origin symmetry. Now, how about cotangent? Cotangent, you can show again using exactly the same method that cotangent, also an odd function. Therefore, it is symmetric with respect to origin. Okay, as you can see here, like this point, let's say on the graph of cotangent x, if you reflect that with respect to origin, you will get something here. Okay, this guy, when you reflect with respect to origin, you will get something here. Okay, now, but then, oh, you can see that the range is all real number. That's the easy question, right? Sorry, that's number 2. The range is all real number. How about the asymptotes? As you can see, the asymptotes are, when x equals to 0 and all multiple of pi after or before that, right? Okay, now, but if we want to confirm analytically, not only by just looking at the graph, analytically, then we see that the asymptotes are given by x equals to, let's find out. You see, cotangent x is undefined when the denominator, which is that's equals to cosine x over sine x, right? When sine x is equal to 0. Okay, when sine x is equal to 0. Let me write that here. Cotangent x is cosine x over sine x. Now, however, cosine x is equals to 0 when the angles are 0 degrees and 180 degrees. In radian, cosine x is 0 when the angle is 0 or the angle is pi or every multiple of that. Okay, so 0 plus pi give me this, plus pi give me that, plus another pi give me this again, plus another pi give me this again. Okay, so sine x is equals to 0 at 0 plus constant multiple of that, integer multiple of that. If we ignore the 0, then x is simply k pi, where k is an integer. Okay, so the asymptotes will be constant multiple of pi, where the constant is an integer, any integer. Now that leads to question part A. What is the domain then? The domain is all real numbers except those x's where sine x equals to 0. Okay, now you may wonder why we need to know this. Okay, another one is the period is pi. The period for sine and cosine are each 2 pi's, right? Okay, but the period for tangent and cotangent only pi. Now for that, then suppose we have this question. I got the question from our textbook right away. Suppose we have, for example, we have number 20 from our textbook 5.6. Okay, we have y equals to cotangent x plus pi over 4. Find the period. Oh, I think the period is easy. The period is pi divided by the coefficient of the angle. So the period is just pi. Okay, how about the asymptotes? We know cotangent have denominator sine, right? So what you need to solve is sine x plus pi over 4 equals to k pi, where k are integers. I'm sorry, equals to 0. I'm too fast. But then when you solve this, x plus pi over 4 equals to constant multiple of pi, where k is an integer. So x will be negative pi over 4 plus k pi. Of course, this statement is equivalent to say 3 pi over 4 plus k pi. See, when k equals to 1, you get 3 pi over 4. Right? When k equals to 1 here, it's the same to when k equals to 0 here. When k equals to 2 here is the same when k equals to 1 here. You see? So these two statements are the same. It gives you exactly the same list of x's. Okay? So the key is really you need to memorize when we sign x, sign blah equals to 0. Okay? So the asymptotes will be all the x's where x equals to 3 pi over 4 plus k pi, where k is an integer. Now then, how about the domain? The domain will be all real numbers except those asymptotes. Okay. Now, suppose somebody asks you, can you sketch the graph? Yeah, I can. What I will do is I get the x-axis, which I will not ask you to graph. Okay. We can write the, yes, you can write the asymptotes either this way or this way. The preference, of course, we use the first number here to be a positive number. Okay, that's the preference, but there's no, if you write it this way, it will be acceptable. Okay, because that gives exactly the same list anyway. Okay, so you can draw, you can use either one of them. Now, if I need to graph it, okay, which I will never ask you, but of course you should be able to imagine that. Suppose this is what happened? Now, suppose this is your y-axis and that's your x-axis. Now, see that the phase shift is negative pi over 4, right? So you will start here, negative pi over 4. Okay, that's x equals to negative pi over 4. Okay, and then you add pi over 2, that gives you the asymptotes. I'm sorry, that's the asymptote already. No. That's the asymptotes already. So that's actually looks like this later on. Plus, give me a second, plus pi. So I have another asymptotes here at 3 pi over 4. I keep on thinking we were dealing with tangent. Okay, and then plus pi, that will be 7 pi over 4. Okay, now for the graph of cotangent, okay, the graph looks like this. From the top left to bottom right. You see that? Okay, so these asymptotes here, originally at y-axis, you shift that pi over 4 to the left. Okay? So that's approximately what the graph looked like. Now, but if you need to find this guy, what is that? You basically solve for the cosine to be 0. Okay, so these coordinates here are the x-intercepts, right? Okay, the x-intercept is when y equals to 0. Zero equals to cotangent x plus pi over 4. If you need to look for the x-intercepts, it means the cosine equals to 0 but cosine is equal to 0 when the angle is pi over 2 or constant multiple to that where the constant is an integer. Okay, so x equals to pi over 4. You subtract by pi over 4, you get pi over 4. Okay, so you will see this is pi over 4. This is 5 pi over 4. This is subtract by pi. That will be negative 3 pi over 4. Like that. Okay, I usually don't ask the x-intercept unless we are done with 6.2. Once we finish 6.2 on Thursday, then I can even more formally ask you what's the x-intercepts. Okay, but for now, we just leave it behind. We focus on the asymptotes, which also tell us the domain. Okay, the complement of asymptotes give us the domain. Basically, the asymptotes, the vertical asymptotes, are those axes we exclude from the domain. Okay, now the shape of the graph for cotangent is from the top right to the bottom left. I'm sorry, top left to the bottom right. Tangent, on the other hand, is from bottom left to the top right. Okay, so you can say that tangent looks like this, cotangent looks like this. Okay, now let me not spending too much time here. Now, this example 1 tells us that the way you solve for, let's say, the period, asymptotes domain, and x-intercepts even more of cotangent is basically you look at the numerator, or in this case, for asymptotes, you look at the denominator and solve it for 0. Okay, now let's see one more. Let's see one more, but this time we will do it a bit faster. For example, number 16. Number 16, y equals to 1/3 tangent 2x minus pi over 4. Now, what is that 1/3 doing there, Thomas? It will change the shape. You basically shrink that vertically, but because the range is already all real numbers, that 1/3 will not change the range. Okay, but it will, this function will have, let's start with period. What is the period? The period is originally pi, but we divide by 2. Okay, so the period is pi over 2. Now, how about the phase shift? Phase shift will be if you factor that 2 out. You see that? So the phase shift is shift to the right, pi over 8. Now, that's something we know already. Okay, now how about the asymptotes? The x-intercept part, for x-intercept, for cotangent. Cotangent is cosine over sine. That's cosine x plus pi over 4 over sine x plus pi over 4, right? Okay, it implies for that rational function to be 0, the numerator has to be 0. Now, cosine what equals to 0? That's when the angle is pi over 2 plus k pi. The same explanation I gave for this. Okay, cosine blah equals 0 means blah has to be what kind of angles? Okay. Now, how about the asymptotes here? How about the asymptotes here? Then it's tangent. So asymptotes when the cosine, the denominator, is equal to 0. Right? But cosine blah equals to 0 when the blah is pi over 2 plus integer multiple of that. Oops. Now when I add by pi over 4, I get 3 pi over 4. When I divide by 2, I get 3 pi 8 plus k pi over 2. So the asymptotes are x equals to 3 pi over 8 plus k pi over 2. Now that also tells us actually the domain. And the domain, therefore, it will be all real numbers except when the denominator equals to 0. That is that 3 pi over 8 plus k pi over 2. Okay, that's for number 16. Is there anything else? For x-intercept, you just solve for the numerator to be 0. Okay, if we want to have solve for x-intercept, then you will do, you need to have tangent blah equals to 0, right? But that implies the numerator sine blah has to be 0, so on and so forth. Give me a second. That's how, you know what, I will need to take more time. Give me like around 10 minutes. I will come back. Give me a second. Yeah, we're coming back for x-intercept. For x-intercept, tangent blah equals to 0, then sine blah equals to 0. Then when sine blah equals to 0 implies blah has to be a integer multiple of pi, like that. Okay, and then you solve further for x. Okay, now so you see this thing, this guy here, and the other guy, let me use another color, the other guy, cosine blah equals to 0 implies blah is pi over 2 plus integer multiple of pi. Those are actually the two key ingredients for what we have done so far. Okay, now let's shift to the second part, the graph of secant and cosecant. Graph of y equals to secant x. Oops, sorry. What happened? I cannot erase it. Yeah, secant x and y equals to cosecant x. Now, but for this one, instead of giving you the graph that I screenshot from internet, I want to share with you what the graph looked like on graphing paper, on graphing software. It's a nice observation. If you see that pattern, it becomes a lot easier for us to graph. So let me start with y equals to cosine x. This is the graph of y equals to cosine x. And remember, the amplitude is 1, right? The amplitude is 1. The maximum is 1. The minimum is -1. Okay, now the reciprocal, therefore, becomes something looks like this. So y equals to secant x. Now the pattern is, I want you to see that the pattern is when you have a bump on the top for the cosine. If you have a bump on the top for cosine, let's go back to the notes where I will screenshot, post my screenshot. Oops. For the cosine, if you have a bump on the top, then the corresponding secant part will be going down. Okay. Now, if the cosine has a valley, okay, then the secant have the peak there. Okay. Now notice that Notice that this is the maximum for the cosine. And this is the minimum for cosine, right? Between -1 to 1. Now take a look what happened to the secant. The secant is actually the complement of that. So if the range of cosine is between -1 to 1, then the range for secant is from 1 to infinity and from -infinity to 1. Do you see that? Okay, so the range for cosine x is between -1 to 1, right? The range for cosine x is -1 to 1. Now the range for secant x is anything but that interval, except that you include the endpoints. Do you see that? Okay, this is the range for cosine. This is the range for secant x. As if all real number, but you take this part away. Do you see that? Now, so with that kind of observation, then we will be able, so this is just observation, right? Only you will understand this picture only if you see my graph. But then suppose later on, for example, I have this y equals to, I suddenly go hard. Okay, y equals to 4 minus 3 secant parentheses 2x plus pi over 3. What will the graph look like? Okay, well, what will the graph look like? What you will do is you look at the cosine version first. Look at cosine version first. Okay, what's the graph look like? Cosine version. The center is 4. The amplitude is 3. So the center is 4. Going up 3, you get 7. Going down 3, you get 1. Is it right? And the graph later on will look like this. Do you remember this? Something we did on Thursday, last Thursday. Okay, the phase shift is -pi/6. The period is 2 pi divided by 2, that's pi. So this is 5 pi/6. Do you remember this? Okay, now then the graph of secant, will be, if it is down bump, the bump is down, you have a valley, then it will be a peak. If you have a peak, you will have a valley for the secant. That's what it looks like. Okay, the blue curve is the cosine version. The black curve is the secant version. Okay. Now, how about the domain? Let's do the asymptote first. The asymptote will be when cosine of that 2x plus pi/3 equals to 0. Is it right? But cosine blah equals to 0 when blah is pi/2 plus integer multiple of pi. Now solve for x from here. So 2x equals to subtract by pi over 3, that's pi over 6. So the asymptotes are all vertical lines, x equals to pi over 12 plus k pi over 2, where k is an integer. The domain will be all real numbers except those axes that become the asymptotes. Now, how about the range, Thomas? How about the range? Now, imagine the cosine version. 4 minus 3 cosine 2x plus pi over 3. This is at most 7. This is at least 1. Is it right? Okay, the range for the cosine is between 1 to 7. Now, so the range for the secant version will be negative infinity up to 1 union 7 to infinity. Okay, because the range for the cosine version is from 1 to 7. You see that? So the range for the secant version is anything but the red interval in this case. Does it make sense? Okay, how to graph that? You can actually graph that really fast by first looking at the graph of the cosine version. Now, let's try to graph this on our graphing software, on my graphing software. I will not ask you to graph, so don't worry. Yes, the red one is the cosine for that graph earlier. The red one is the cosine. The black one is for the secant. Okay, now let's see what the graph look like on the graphing paper, the graphing software. So we have that 4 minus 3 cosine, parentheses, 2 theta plus pi over 3. Is it right? That's what it looks like. And we have 4 minus 3 secant 2 theta plus pi over 3. Oh, I'm sorry. Now I see my mistake. I should not use theta here. It becomes a polar coordinate system. That's what it looks like. Let me make it smaller. You see that? The purple color is the cosine version. The red color in this picture here is the cosine is the secant version. Okay, so you see that when the cosine is on the top, on the peak, the secant version is on the valley. Okay, when the cosine is on the valley, the secant is on the peak. They actually meet at the maximum and the minimum. You see that? Okay. And while the purple color has ranged from 1 to 7, none of those from 1 to 7 has red color. The red is actually outside of that 1 to 7, except at y equals to 1 and y equals to 7, exactly. Okay, so let me screenshot this to provide you a better picture. Okay, so what happened is this is the maximum for cosine, and this is the minimum for cosine. Okay, notice that the range for cosine is between 1 to 7. Yet the range for secant is, the range for secant is 7 to infinity and negative infinity to 1. You see that? Okay, now that's for secant. How about cosecant? The same work. Cosecant is the same. So let me go ahead with, for example, question, let me see. Do we have a cosecant? Number 40. Number 40 in our textbook. Y equals to cosecant x plus 3 pi over 4. Oh, okay. The period is pi. Oh, hold on. Am I already going back to, oh, here? I'm sorry. I'm here. This is what I said earlier. This is what I said earlier. So this is the range for cosine, right? 1 to 7. And this is the range for secant. Okay. This is when y equals to 1. This is when y equals to 7. Okay, let's see number 40. Y equals to cosecant x plus 3 pi over 4. The period is pi. That one is easy. The period is pi over the coefficient of the angle. Okay, here the coefficient is 1, so the period is the same. Actually, we can say that this is the phase shift, negative 3 pi over 4. Okay. How about the asymptotes? Then the sine of that angle has to be 0. Oh, what am I doing? The period is 2 pi. Thank you. The period is 2 pi. The period is 2 pi. Thank you, thank you, thank you. The period for cosecant is 2 pi. The period for tangent and cotangent is the 1 pi. Tangent and cotangent, the period is pi. But secant, cosecant, it follows the period of sine and cosine. Okay, okay. It's my it's my fault. It's my fault. Yeah, secant and cosecant follow the period of sine and cosine. Okay, respectively. Thank you. So let me see. I think I make a mistake here then. It's supposed to be plus 2k pi. Oh, no, no, no. This is for 0. That's right. That's, the 0 is, that's right. I thought I make mistake everywhere. So sine equals to 0 when the angle is constant multiple of pi. Now subtract by 3 pi over 4. That's what it looks like. Now, if you add 1 pi, it becomes pi over 4 plus k pi, just to make it positive. Okay, just to make the constant part is positive. But you can use either one of them. You can use either one of them. Okay, so the asymptote is x equals to pi over 4 plus k pi. For the before causation, the graph is wrong. The one I have here. The one here, the one I have here. I don't think so. I think I'm fine here. When k equals to, it reached the minimum at x equals to negative pi over 6. That's approximately 1/2, right? Negative 1/2. Let's check here when x equals to approximately 1/2. Here, right? That's when x is approximately 1/2. Let me erase this so that we can see better. So this is x equals to negative 2, x equals to negative 1, x equals to negative 1/2. That's the minimum. The period, no, the thing is, so for this question, right? For this question, I didn't ask the period. The period is 2 pi. However, cosine reach 0 every pi. Cosine reach zeros every some x, right? In this case, pi over 2, and every pi after that, and every pi before that. So even though the period of cosine is 2 pi, okay, the period of getting zeros is pi. Oops. Does it make sense? Instead of 5 pi over 6, it's 11 pi over 6. Oh, I see what you mean. Okay, okay. So it's this one. Thank you. So it should both be 11 pi over 6. Thank you, thank you, thank you. But, oh, hold on. I think I was right. That's 2x. The angle is 2x. Why am I so confused today? Huh? The coefficient is 2x. Right? Yeah, the coefficient is 2x. Yeah, so it's so that's right. That's 5 pi over 6. So I was right. I was the one confused. Okay. So the period is 2 pi over 2. Yeah, that's right. Okay, the period is 2 pi over 2. The period is 2 pi over 2. And actually you can see that here when we solve for x for the asymptotes, okay, when we solve for asymptotes, notice that in one period, or in this one period, there are 2 asymptotes, right? So if the period of the secant is pi, then the period for the asymptotes will be half of that, pi over 2, like that. The period for the asymptotes, okay? But the period of the graph still pi for that example, or this example here. Now, let's come back here. So you see the period of the asymptotes here is pi, right? Okay, the period for the asymptotes. Now the period for the graph is 2 pi. Does it make sense? No? I hope so. And then how about the domain? The domain is easy, is all real number except the asymptotes pi over 4 plus integer multiple of pi. How about the range? So you see the sine version is -1 to 1, right? If you change that to sine, y equals to sine something, then the range will be -1 to 1. The center is 0, the amplitude is 1. So the range of this cosecant version will be -infinity to -1 union 1 to infinity. Okay, now this is the type of question that if you don't study well in advance, it will take you too much time to look at the notes during the test. You know, so students who run out of time during the test, that's because of this. Okay, it seems like I spent too much time on this section. Yeah, it seems like I spent too much time on this section. Suggested homework from here. Let me just pick some instead of doing so many. Suggested homework from here. From 5.6, I would like you to do think about number 9, number 9, number 27, number 37, number 40, 45. Or of course you can do more if you like, but when you do these 4 problems, focus on the asymptotes. Usually you get the asymptotes first and then help us with the domain. And then how about the range? Okay. Once we're done with 6.2, then we will answer the question X intercepts. That's after you do 6.2. Okay. I supposed to go to, seems like I need to postpone 6.1 until Thursday. Oh, I don't like that. Okay, 5.7 is on applied problems. It's basically the following. 5.7 is solving triangles using right triangles. Yes, chapter 6.1 will be in the test. 6. The proofing will be in the test. Yeah, proofing will be in the test. Your test will be on Wednesday and Thursday anyway next week, right? Wednesday and Thursday. So even if we do that 6.1 on this Thursday, we still have fine. We still have 1 week. Okay, it's not too tight. Yeah, it's important material though, but it's not too tight. Now, what we will do here is basically using right triangle to solve a problem. Now we will attack the problem, application problem, by doing the following. Suppose I have an angle. Okay, suppose I have an angle and we are given, let's say I go ahead with number, let me go ahead with number 9. Okay, where angle alpha is 37 degrees. So I'll sketch the graph though. Okay, the angle alpha is 37 degrees and side B is 24. Gamma is 90 degrees. So alpha corresponds to side vertex A. This is B for angle beta. Now, now, find the remaining parts. So what is angle beta? For example, what is side A? What is side C? Okay, while we only know these 2 facts and this one, of course. Now, the way we will do it, suppose I want to find out A first. So think about what is the relationship between A and 24 and 37 degrees. What trig functions relates these 3 numbers? To find A, the trig function relates these 3 numbers is tangent, right? Tangent 37 degrees is A over 24. Are you with me? Okay, now then A is equal to 24 times tangent 37 degrees. Then you use your calculator. Remember, round it to 5 decimal places. And remember, make sure that the mode is correct. The mode in this case is in radian. 24 tangent 37 degrees is 18 point something. 18.08530 equals to A. Now, how about C? Side C. What relates side C with 24 and 37? That's cosine, right? That's cosine. So you say cosine 37 degrees is 24 over C. So C is equals to 24 over cosine 37 degrees. 24 divided by cosine 37. So C is equal to 30.05126. The easy one, of course, what is angle beta? Angle beta is the complement of 37 degrees, right? Beta equals to 90 degrees minus 37 degrees, that's 53 degrees. Okay, that's on the easy side. Now, how about if we have the sides instead? Number 15. We have a right triangle. Let's say this is A for alpha, angle alpha. C is a right angle. B correspond to angle beta. So this is side B, this is side A, this is side C. What that tells us is side C is 5.8. This is given. Side B is 2.1. That is also given. Okay, so can you find side A? What do you do? Pythagorean theorem, right? A squared plus B squared equals to C squared. A squared plus 2.1 squared equals to 5.8 squared. A squared is equals to, let me just, 5.8 squared minus 2.1 squared. That is 29.23. So A squared equals to 29.23, such that the A is equals to square root of that. 5.40648. Now, how about angle alpha? What relates angle alpha with the yellow? That's cosine. Cosine alpha equals to 2.1 over 5.8. So alpha will be cosine inverse. It's a right angle anyway, right? Cosine inverse 2.1 over 5.8. I get 68.77269 degrees. Now angle beta, that's the complement of angle alpha, right? Or you can also use sine beta, right? The relationship between angle beta and the yellow ones is sine beta equals to 2.1 over 5.8. But I still prefer to use just do the complement. Yeah, just do the complement. You will get the same number. Okay, that will be 20.22731 degrees. I mean 21. Now, that's the foundation of what we will do in the later part. Let's take a break first. We come back at 9. Right now it's 9:22. We come back at 9:32. If you watch my lecture video, lesson 18, as I remember, I think it's lesson 18 or lesson 17. I think it's lesson 18. Now, if you watch that lecture video, you see that I have done quite plenty examples from our textbook, especially the word problems. So please make sure you watch that one. I will do 1 or 2 more questions from here. And then after that, I will show you a type of question that is not in the book, but doable already at this point. Okay, keep in mind one important principle when it comes to calculation. If the angle is one of the special angles, like 30 degrees, 60, 45 degrees, 60 degrees, then you need to use exact value for its trig value. Okay, now suppose, for example, I have this question. It's not in a book yet. Yeah, 60 degree. Who wrote that 65? Suppose we have this question. So I have this triangle here. Okay, where the angle here is, let's say this is A and this is 60 degrees. This is 10 and this is 15. The question is find what is side A. Now this question, if you go far enough into into trigonometry, I think in chapter 7, you will see that we can solve A here using law of cosine. Okay, but before we use law of cosine, can we compute this using what we learned here so far? The answer is yes, we actually able to compute this already. Okay, we can find A already. The procedure is longer, of course. Okay, what I will do first is I will draw the altitude of this triangle from the top vertex, from the top, the top vertex. Okay, then I will first find the length here. Okay, I will find that length. I tell you the plan first. I will find that length. And then I will also find the length here. You see that it's a right triangle. So the blue, the one I highlight in yellow and the one I highlight in blue, actually computable, right? Now, then we will be able to find the length here. Is it right? Just subtract the yellow from 15. Then finally, using Pythagorean theorem, we can find A. Is it okay? Now, let me first call this point D, and this is point B, the vertex B there. So what is AD? AD in relation to 60 degree and 10, that's cosine. Cosine 60 degrees is AD over 10, right? Okay, so cosine 60 degrees radical 3 over 2. That's AD over 10. So AD is equal to, multiply by 10, both sides, that give me 5 radical 3. BD, on the other hand, well, cosine 60 is 1/2. What am I doing? So it's just radical 3. Duh. It's just 5, not radical 3. It's just 5 here. Cosine 60 is 1/2. Now then sine 60 degrees that's the one radical 3 over 2. But that is equals to BD over 10. So BD is 5 radical 3. Now what is DC then? AD plus DC equals to AC. Okay, 5 plus DC equals to 15. So DC is equal to 10. Now then, side A squared equals to BD squared plus DC squared. That is 75. I get it from here. 5 squared is 25. Radical 3 squared is 3. So that's 25 times 3 plus 100. That's 175. That's 25 times 7. So the A equals to 5 radical 7. Now, what I meant by if it is special angle, you need to use exact value, that's what I meant. You don't make it into decimal here. Don't make it decimal. This one here, don't make it decimal. Okay, don't make it decimal. But if you don't have special angles, like say 37 degrees, like what we had earlier, then you use calculator. Okay. Number 27. Airplane landing. A pilot flying at the altitude of 5,000 feet. So you have a plane flying at the altitude of 5,000 feet. Wishes to approach the numbers on the runway at an angle of 10 degrees. So this is the, let's say you have a runway here. There are numbers here, right? Now it wants to approach that at the angle of 10 degrees. Okay, approximate to the nearest 100 feet the distance from the airplane to the numbers at the beginning of the descent. So the question is, what is the distance here? What is that in question? From the airplane to the numbers at the beginning of the descent. So basically the one I highlight in blue here will be the trajectory or the path of the airplane. Okay, now what will that be? Let's call that C. Just call that something. You can call that X if you want. Okay, let's call that X. Why not? I love my X. No pun intended. Okay, so what relates 5,000 feet, 10 degrees, and X? That's the sign, right? Sine 10 degrees equals to 5,000 over X. So X is 5,000 over sine 10 degrees. Right? I get 28,793.85242 feet. That's if I try to be 5 decimal places accurate. Now, if we round to the nearest 100 feet, to the nearest 100 feet, that X will be, you round it to the nearest 100, that will be 28,800 feet, right? To the nearest 100 of feet. That's not what I get. 5,000, not 500. 5,000 feet. Okay, 5,000 feet. And it won't be 2,000 something. One of our friends say X supposed to be 2,879 something. Now it won't be. Why? Because this is the hypotenuse, right? The hypotenuse is supposed to be longer than one of the leg. So it's definitely not 2,000 something. Oh, okay. Yeah, it won't be 2,000 something. It must be 20. It must be more than 50. It must be more than 5,000 feet. Here we get that the plane supposed to start the descent once it is approaching 28,800 feet from those numbers. It's like on the runway, there's a number here that tells you which runway should you land on. Okay. Okay. So there's a number of the, what you call it, the runway. Okay. And there are also numbers here that tells you the distance to the end. Okay, the bigger the plane, the more distance it takes to actually stop, right? Not to say that sometimes at certain numbers, then you need to turn to your gateway, like that. So they already tell you, okay, you know what, because your gateway is here and you need at least what distance to stop, okay, to come to a normal, regular driving speed instead of flying speed, then so let's say that's the distance needed. Okay, so he needs to land here or earlier than that, like that. Okay, so at what distance he will start to do the descent. Okay, with the same question, you can actually, with the same idea, you can actually find the horizontal distance on the ground. You can call that y, right? Okay, so tangent 10 degrees equals to 5,000 over y. Okay, if you want to find the y. I think this is where I will stop for that 5.7. Make sure you watch the lecture video for more examples. Okay, but all of these questions here, especially the word problems, for all these questions here, one of the key initial step is to sketch the situation. And when you sketch the situation, try to catch a right triangle. So when I sketch this situation we have here, I catch this right triangle here. That becomes the key and focus of our analysis. Okay, try to grab a right triangle because we can only work, so far we can only work our trigonometry in a right triangle. Okay, in the right triangle context. Okay, your suggested homework from here will be 5.7, number 1 to number, I think you can go up to number 39. Do the odd ones. There are more things we can do with this though, with this with this right triangle, even though it seems to be very simple. But let me show you the variation of problems that makes you more mature. At West LA College, I believe I told you before, the prerequisite for pre-calculus class is trigonometry. Okay, so in my pre-calculus class at West LA College, I don't really talk about the examples I gave you here anymore. No, we don't do that. Okay, the questions I gave them is, for example, the following. Okay, for example, a balloon is observed by observers A and B. So you have a balloon, okay, being observed by A and B. Okay, at the angle of elevations let's say 35 degrees and 40 degrees, 41 degrees. A and B are, let's say, 600 feet from each other. Let the balloon be in between them. So let's say this is A here, 35 degrees. The B here is 41 degrees. And the distance between A and B is 600 feet. And the question, and the balloon is between A and B. Okay, find the altitude of the balloon from the level of A and B. So basically the one in question is, what is this? Now Now, to do this question, you need to be more mature mathematically, which I do expect you have since you are done with polynomial and rational function. Okay, now let's first call this, let's call this x. So you see that you have this right triangle here, right? Okay, and you will also have this right triangle. Does it make sense? Okay, you have those two right triangles. Now, if this is x, then this will be 600 minus x. Is it right? We need to find the h. So on the left triangle here, we see that tangent 41 degrees is h over x. While on the triangle on the right side here, we see that tangent 35 degrees is h over 600 minus x. So how do we solve this? Well, let's see the left-hand triangle. We have x tangent 41 degrees. The right-hand side triangle, we have 600 minus x times tangent 35 degrees equals to h. You can set them equals to solve for x first. Once you get x, then you solve for h. Okay, so x tangent 41 degrees is equal to 600 minus x times tangent 35 degrees. Now, you start feeling that this question is not on the easy side for you, right? But this is pre-calculus level, though. This is pre-calculus level. Can you answer this question without using the material from chapter 7, law of sine, law of cosine? Okay. Now then from here, let me just finish this. Okay. This is x tangent 41 degrees equals to 600 tangent 35 degrees minus x tangent 35 degrees. And then I combine the x's together. Thomas, can I just use calculator and change that tangent 41 degrees and tangent 35 degrees? Actually, yes, but if you do it now, you may end up with too much rounding error. So let me, instead of getting an ugly 5 decimal numbers, let me just keep them as tangent 41 degrees and tangent 35 degrees for now. In fact, can we find the h without rounding anything? Like give the exact answer. And that's what I'm trying to do. I factor the x out. So x is 600 tangent 35 degrees over tangent 41 degrees plus tangent 35 degrees. Okay, that's the x. Okay, now h is, I will use this one. H is x times tangent 41 degrees, right? We know our x is what we have above, so it will become 600 tangent 35 degrees tangent 41 degrees over tangent 41 degrees plus tangent 35 degrees. Now that's the exact solution. That's the exact solution. The variation of this question that you can try working on, what if the balloon is not in between? So it looks like this. It looks like this. A and B are here. Okay. And the balloon is here. Who is 35? Who is 41? The B is 41. Yeah, that's right. So this is 41 degrees. And this is 35 degrees. This is the H. This is 600. Let's call this X. Okay, so you will have two triangles, two right triangles. This is one. And this is the other one. You see that? Okay, now you set up the system of equation and then solve for X, then solve for H. Okay, let me guide you. I will not do this in full, but I will just give you the equation you need to solve. So for this triangle here, we will get that tangent 41 degrees is H over X. While the bigger triangle, we have tangent 35 degrees is H over 600 plus X. Now, those are the two equations you need to solve. Okay, now another type of question, this is actually one of the very well-known question, very well-known type of question, is the mirror problem. So suppose you are standing in front of a mirror. Okay, that mirror is known to be, let's say, 3 feet. Now then, when you look at yourself there, the angle of elevation from the horizontal, let's say, is 10 degrees. And the angle of depreciation to the bottom of the mirror, let's say, is 20 degrees. Then the question is, what is your distance from the mirror? Now, I will not do this in full, but I give you the idea. Suppose we call this X. So this will be 3 minus X. Right? Now then, on the top triangle, you get tangent 10 degrees equals to X over D. And on the bottom triangle, you get tangent 20 degrees is 3 minus X over D. That's what you need to solve. Okay. So the name for this balloon problem, this problem here, in this example, you should call balloon problem or satellite problem. So you can change the balloon to satellite, and the question basically becomes very similar. Okay, or you can call that a plane. Can you tell how high is the plane from the ground if you have two stations observing that plane at the angle of 41 degrees and 35 degrees, while those two stations are, let's say, 6 miles away from each other? Can you find how high that plane from the ground? Okay, and the one here, they call that mirror problem. Okay, but we can easily change this type of question into the antenna problem. So you have, let's say you have a hill and you are actually standing here. Okay, now we don't know my distance to that hill, but I know that the height of that antenna, let's say 20 feet. Suppose my angle of elevation to the bottom and to the top of that antenna are known to be, let's say this is, let's say 12 degrees, and this one here is 15 degrees. Can I then find my distance to my distance from on the ground to the bottom of that hill right below that antenna? Can I find that distance? You see? So to do that, then you assign a variable x here. Okay, and then set up the triangle again. There should be two triangles you're working at. The small triangle and the bigger right triangles. Both of them has to be right triangles. This is D, this is x plus 20, and this is 15 degrees. This is 12 degrees, by the way. Okay, so those are the two triangles you work with. Okay, try to answer this question though. If once you're done with suggested homework I gave you here, okay, just do every other odd first if you want to save some time. Okay, and then start working with this this type of question. Try to follow through this example I give first, and then start working on the red one. You can ask me on Thursday, Thomas, did I get it right? You know. Okay. Now if you find it's difficult, then think more. Okay. Yeah, then we talk about that on Thursday during my office hour. So let's say these three questions here, the follow-up question, if the balloon is not in between, the mirror problem, and the antenna problem. Yeah, try to do that and ask me on Thursday if you want. But we'll do that during my office hour instead of my class time. Okay. Now 6.1 on proofing. 6.1 verifying or proving trig identities. Okay. Make sure you watch the videos. I believe it was in lesson 17. See lesson 17. When I went over proving identities. There are three lessons. There are three topics in lesson 17, as I remember. But the verifying trig identity is actually the second one. Okay, basically you will see the following. Okay, trig identities, identity looks like this. You have left-hand side expression equals to right-hand side expression. You need to prove it. Now, when you prove that, you need to first decide the direction of your proof. Either you prove from left to right or from right to left. Okay, now if you start from left-hand side to right-hand side, then you write LHS first and whatever the expression you have on the left-hand side. And then you do one step per line. Okay, when you do proving, don't skip steps. Okay, when you do proving, show one argument per one step, and the next step should be done in the next line until you have the expression on the right-hand side and then you close the proof with this square. Okay. If you start from right-hand side, basically the same. You write right-hand side equals to whatever that is, whatever you see on the right-hand side. And then one step at a time, one step, one line until you reach left-hand side. And then you close the proof with this notation. Okay, the square that you fill up. Now, in the last 10, maybe even 15 years, or maybe even 20 years, that at the end of the proof, we use this notation. In the past, we use QED. In the past, we use QED to mark at the end of the proof. Now we use a filled up square. Okay, now instead of spending too much time in the technicality, but I need you to show me that technicality also. Okay, that's the right way to do it. That's the right way. Okay, when it comes to proofing, you may think, oh, Thomas, it's so obvious for me. Okay, but therefore I don't need to write it. But if it is not obvious for you, what you're going to write? Okay, so when it comes to proofing, show the steps. Okay, when it comes to proofing, show the steps. Now let me pick question, let's say question number 7 in our textbook. Prove or verify this identity 1 plus cosine 3t over sine 3t plus sine 3t over 1 plus cosine 3t equals to 2 cosecant 3t. Now, when we prove, we try to prove from the more complicated side, in this case, left-hand side, to the other side. So my direction of proof will be from, in this case, from left to right. Okay, suppose you decide to prove from left to right, then use that notation first. Second, write these letters, LHS, that stands for left-hand side, equals to whatever you see on the left-hand side, 1 plus cosine 3t over sine 3t plus sine 3t over 1 plus cosine 3t. Don't do any computation, any simplification, nothing. Just copy paste. You just copy paste whatever you have on the left-hand side. I want to skip step, Thomas. Can I just go ahead and do some simplification? No. No. That's what you need to write. Okay. But my other teacher, okay, why don't you pass that other teacher? Okay, so don't compare me with other teacher. Okay, that's out of line. That's rude. Okay, you don't pass that teacher and you ask me to actually follow what that teacher. But Thomas, I passed that class. Then why are you still here? Okay, no. Don't do that comparison. What I'm teaching you here is the most acceptable method to show proofing. Okay, I don't do a lot of proofing in this class, and verifying trig identity is actually on the easy side of proofing. Once you go to calculus 1, especially with some teachers, they want you to do a lot of proofing at that time. Okay, there are some procedures you need to show. Okay, there are details that you need to show. Okay, and this is the foundation, the early part of showing work when it comes to proof. Okay, the first line, directional proof in an identity. We start from left-hand side to right. So left-hand side equals to this. Okay, next. When we prove one step at a line, and there are some things we can do. For example, one thing we can do is to multiply by the conjugate. Okay, right? For example, the one on the right-hand side here. Okay, I will multiply by the conjugate. The first term, I keep it the same. The second term, I will multiply by the conjugate of the denominator. What is the conjugate of the denominator? Every time you hear the word conjugate, it means it's two terms, the same two terms, but opposite sign in between. That's what we meant by the conjugate. Now, the purpose of multiplying by the conjugate is to take advantage of difference of squares. Now, notice that in the next line, whatever I don't process, I still copy paste. Okay. Now, the second term instead, it becomes sine 3t times 1 minus cosine 3t. I usually don't distribute that right away, but if you want to, go ahead. I usually don't. Okay, over the difference of squares. That's the purpose we multiply by the conjugate, so that we can take advantage of difference of squares. There will be 1 squared, which is 1 minus cosine squared 3t. But 1 minus cosine squared 3t is sine squared 3t. After that, we will cancel with one of the sine t on the top, right? But after that, when we say after that, that's something we do later, not now. What I do now is 1 minus cosine squared is sine squared. Agree? Can I cancel the sine 3t? Yes, but you do it later, not now, not at once, step by step. Can I just skip that step, Thomas? Yes, you can, as long as you allow me, as your teacher, to skip steps. If you don't let me skip steps, you have no right to skip steps. It's just not fair, you know, at least from this kind of conversational level. It's not fair that as a teacher, I need to show all the work, but then you as a student, you don't need to show all the work. Bangs, all of a sudden you get the answer, right? Out of nowhere. No, that's not how we do things, right? Okay, that's not how, and especially when it comes to proof, okay, show the details. Okay, show the details, show it in a way such that whoever read it has no way to complain or to criticize or to say, how do you get from here to there? You know what I mean? Okay. If you learn a bit about statistic, okay, or just a human psychology, okay, how can you tell somebody's actually lying to you? Let's say Thomas going out from his from home for like 4 hours, so 5 hours, and then when he came back home, you ask him, hey Thomas, where did you go? Oh, I went to shopping at Ralph. What? You go to Ralph for 5 hours? I mean, how big is that Ralph? You see what I mean? Okay. Oh, this thing happened, that thing happened. Okay. Then somebody will ask you again, what happened? It's like, well, okay, let's say somebody got an accident there. Okay, this happened, that happened. Okay, but what it has to do with you? You see what I mean? So it has nothing to do with you. Why do you need to stay 5 hours there? You must be going somewhere else. Did you go to casino, Thomas? Right? Okay. So if there's a hole in between of your explanation, very likely you are lying. I mean, that's how we detect somebody lying to start with. Okay. So if you skip steps, it's very likely it's because you don't know what happened in between. And all of a sudden from here, you jump to, oh, that's equals to this. Dang. You know, I will put a question mark. How do you get that? Okay. I know it, Thomas. I just don't write it down. Okay, well, I know you're supposed to get the grade, but I don't write the grade. What do you think if I give you that accident? I give you points for things you don't write just in my mind. I give you points in writing for things you write. I give you points not in writing for things you don't write. Is that fair? You don't like that. Okay. Imagine if you say to me, I'm saying this to you as a student, not that I want to be harsh. No. I'm telling you the logic behind it. Okay, the logic behind it. I need to grade you based on what you write, not based on what I think you want to write. Okay, that's actually the very definition of bias. If I judge you based on things other than what you write, that's bias. Okay, but you know, Thomas, I know it. Well, I know, but because you don't write it down, I cannot write it down. You know, Thomas, I'm an A student. Yeah, I know you're an A student, maybe. Okay, but what you show me is a C work, then I give you the C. That's the only grade that I can defend based on what you write. Okay, but I cannot give you the grade based on my personal subjective judgment. I need to grade you based on what you write. That's why, by the way, your test takes some time. Okay, I have to be honest with you. Each test that I give you, even though there are only like 10 or 12 students taking it, it usually takes me 2 or 3 days to grade it. Okay, if I don't have busy days, like Monday and Wednesday are my busy days. Okay, and Saturday or Sunday are days I really dedicate for my family. Okay, so just to grade your test, it will take like at least 4 or 5 days mixed together. Okay, and I just finished the test for Monday, Wednesday class on, I think is it on Sunday morning? Yeah, so I'm still working on your tests too. Okay, but as I expect, I should have finished that tonight. Now, let me go on. I talk too much, huh? Yeah, I want you to realize that even though there's only one problems that I go over now, together with more, I will do more problems on Thursday. But follow that principle, one step at a time. Okay, one step at a time. From here to here, the step is clear. Here to here, the step is clear. Okay, don't jump, don't skip. Okay. I hate it. I hate it to be in a situation where I know you know it, but you don't show the work. Because you put me in a dilemma. Should I give you the points based on what you write, or give you points based on what I think you know? But once I get into that situation, I have to grade you based on what you write, not based on my subjective thinking. You see what I mean? Okay, so the next step. We have LCD already, so sine 3t is equal to, on the bottom, on the top, I get 1 plus cosine 3t plus 1 minus cosine 3t. And the cosine 3t cancel. Can I just skip this step and go ahead to 2 over something, Thomas? Not supposed to, I know, but no. Just show that. Okay. I think the last step that I show you here, you can skip. You can just go ahead to say that this is actually 2 cosecant 3t. Okay, if you want to skip this one here. If you want to skip this one here. And just say right away, this is 2 times cosecant 3t. That's actually reasonable. Okay, but from here to here, that's not reasonable. Okay, from here, jump right away to here. No, that's not reasonable. Okay, my teacher, my professors say this when it comes to proving. When it comes to proving, if you wonder if you should write the step or not, then write it. Okay. What happened, Thomas, if I don't think I need to show that work? Then that's where you may miss it. But if you ever wonder, should I show the step or not, then show it. Okay. Now, at the end of the proof, once it is equal to the other side, then you close that with equals to the right-hand side and close it with the box. It's actually a square that you filled up, that you shaped. Okay, now the emphasis are the following. First, the first line has to be the direction of the proof, the side you start, and what that expression on the side you start. In this case, you start from left-hand side. Okay. Now then, the work in between, one step at a time. One step, one line. Do not show your work horizontally. Like, do not show this is equals to what, equals to what, equals to what. No, don't go to the right. Don't go to the right. Go to the next line. The next step should be written in the next line. At least at your level for now. Okay, now once you reach the right-hand side, okay, close that in the next line with equals to RHS, that stands for right-hand side, and then close it with the shaded square. Okay, now I will do more problems on Thursday, but I would like you to do some first. Okay, watch the videos and do some. Your suggested homework from here, from 6.1 will be number 5 to number, number 5 to number 25. If I were you, I will do the odd ones. Okay, if you want to do the even ones, that would be great. On this Thursday, maybe I do it this way. On this Thursday, I will start by answering questions on 6.1. Only when you ask me question, then I will answer that question from 6.1. Okay, and I may want to see what you have done. So suppose you ask me, Thomas, oh, I'm sorry, not up to 25. I see the wrong number, up to 49. Up to 49. Up to 49. So let's say, Thomas, can you show the work for number 39? Right? Then I will ask you first, can you show me what you have done with your number 39? I will want you to share your screen with me. But Thomas, it makes me don't want to answer questions. Well, it makes me don't want to ask any question. Well, at least I want to see if you try anything. Okay, what I don't want to happen is you don't try anything and you just don't want me to do. Can you do everything from number 5 to number 49, Thomas? No, you need to do something first. Okay, you need to do something. So on Thursday, we will start with answering questions from 6.1. Let's say we dedicate around half an hour for that. And then I go on with 6.2, 6.3. Okay, see you then.
Thank you.
You're very welcome.